Let's try graphing another example. These are very similar to the ones that are on your practice test 4 that you have. The equation that we're trying to solve is y is equal to x plus minus 2. Previously, when we said we could pick values, we could pick either x or y. In a particular case where y is on one side and everything else is on the other side, it's always easier to just pick a value for x because everything that is added or subtracted together is on the side with the x in this example. So if one of the variables is clearly by itself, the other variable would be the one that you would want to solve for. Okay, so we're trying to solve y is equal to x plus negative 2. The values in our t-bar chart that are in black, the ones that are on the left, are the ones that I chose. And you go ahead and use substitution like we did on trying to find if an answer was a solution to an equation. We use substitution and replace the x by the value that we're assigning it, which in this case I'm picking 0. So we have 0 plus negative 2 gives me negative 2. So when x is equal to 0, the only possible value of y is equal to negative 2. So the numbers that are in blue and have an underline are the ones that are calculated. The next value of x that I choose is 1. If x is 1, we have 1 plus negative 2, so y is equal to negative 1. So we have an ordered pair of 1, negative 1. The next number I'm choosing is the number 2. 2 plus negative 2 gives me 0, so y is equal to 0 when x is equal to 2. You might want to try a couple more values, like choose x is equal to 3, x is equal to 4, and go ahead and substitute those in and try your own as well. After I have my 3 points, then I go plot the points that I have. So the first point I have is 0, negative 2. When x is 0, I don't go left or right, but I go 2 units down. So my first point is 2 units below the x-axis. My next point is positive 1 and y is negative 1. So I go right 1 and then down 1 for the point 1, negative 1. My next point is the point 2, 0. X is equal to 2, I start at the 0, 0, I go 2 units left, and 2 units right, and because the value of y is 0, you don't go up or down, so that point is on the y-axis. Here we have another point over here, so you could try to solve it. This point is the point 5, 3, when x is equal to 5. 5 plus negative 2 would give us a 3, so you can see how that point fits on. And as I suggested, you might want to try and see what you get when x is equal to 3 and when x is equal to 4. All of the points should be on this line. After you've drawn your 2 or 3 points, then you connect the dots, and that is the entire solution to the equation. We have just picked several instances here. In this case, I picked the 0, 1, and 2 values and just solved for three examples. So what I'd like for you to do now is to pause the video and try graphing these problems. You can graph them on your own graph paper, which remember you can get underneath the lecture notes for this week, or you can Google and look for free graph paper and try to get those. So what the first thing you're going to do is draw a t-bar chart. I'm very simple. I like to use the values when x is equal to 0, 1, and 2, and always use those values. But you can choose anything that you would like to solve. The second one is y is equal to negative 4x plus 2. So go ahead and draw your t-bar chart again. I would pick values for x. I would pick 3 of them. The numbers can be anything. They can be 0, 1, and 2 for x. They could be negative 1, negative 2, negative 3. Make the math easy for you on the points that you pick. If you have a hard time getting the math with the point you pick another point and see if it makes it easier. After you've tried these 2 problems, then the solutions are on the following page, on page 12, so you can check. Even if you didn't choose the points that I chose when x was equal to 0, 1, and 2. If you chose another point, then that point should have fit on the same line, so you should be able to see that there are other points on these as well. We've learned how that we can choose our points when we're trying to draw our t-bar chart and to get a picture of what our graph looks like. The method that I'm going to show you here is one that is your choice to work. You don't have to work them this way. You can if you want to. Sometimes it's a little bit easier. It's called using the x-intercepts and the y-intercepts to graph. What it means is actually that the x-intercept means it's the point where the x is going to cut, where the value of it is going to cut the x-axis. So it's like the x-axis cutter, or it's the x-intercepting point. So to find the value of x, you let y equal 0 and solve for x. So this is going to be the point because the point is going to be on the x-axis and y is equal to 0. That point is called the x-intercept. The y-intercept is very similar. It's a point when x is equal to 0. What is the value of y? In order to find what the value of y is, you set x equal to 0 and you solve it for y. So the y-intercept is the point where the y-axis is intercepted or it's cut. So we have two things here: an x-intercept, it's the x-axis cutter or the interceptor, and the y-axis cutter at the point where the y-axis is cut. So in summary, to use this method for graphing, the first thing you do is find the x-intercept. That means that the value of y is equal to 0, and then you must calculate and understand and get the value for x. The second thing is to find the y-intercept. This means that you set x equal to 0, and then you must calculate the value for y. And then third is to pick an optional third point, anything of your choice. Again, that third point is optional if you do it, because 2 points always make a straight line. So again, it's just used for a safety measure. So we're going to try graphing an equation using this method. Our equation is x plus 2y is equal to 4. So what we do here is the values that are in black are the ones that I chose. The ones that are in blue and the ones that are underlined are the ones that we solve for. So our first thing that we do is I choose x is equal to 0. I substituted in the above equation, so when x is 0, I have 0 plus 2y is equal to 4. So that means 2 times y is equal to 4, which has to mean that the value of y is equal to 2, because 2 times 2 gives us 4. So we have the y-intercept. The next thing we want to do is solve for the x-intercept. This means that we set y equal to 0. So on the second line there, you can see the black 0. We need to calculate what the value of x is, and that one is the one in blue that's underlined. So what we do is we replace the y value by a 0. So we have x plus 2 times 0 is equal to 4. That means that x is equal to 4 because 2 times 0 is always 0. So we just have x is equal to 4. So now we have our x-intercept. The value of x is 4 and the value of y is 0. We're going to pick any optional third point. So I happen to pick x is equal to 2. So when x is equal to 2, I substitute it in and I get 2 plus 2y is equal to 4. So that means that 2 times y has to be equal to 2, because if x is 2, we know that we need that 2y to equal the value of 2. So the only way that that will happen is when the value of y is 1. So if we check it, we have 2 plus 2 times 1 is equal to 4, and that does indeed, 4 is equal to 4. So again, the ones in these examples, the ones that are in black are the ones that I chose. The numbers in blue are the ones that I calculated. And we go ahead and graph it. And this is what the graph looks like, plotting our 3 points and connecting the dots. Now what I'd like you to do is to try this problem using this method. 3x plus y is equal to 6. And I've given you a hint here. You want x to be 0. You want y to be 0 on the second one, and then choose x is equal to 1 for your third point. Go ahead and try that. Pause the video here at this point. Go ahead and try the problem and check your answers. On your homework, problems 15 and 17 are similar to the one that you just worked and checked your answer on. On those two problems, I would probably just try to do the 2 points, choose x equal to 0, solve for y, y equal to 0, and solve it for x. If you take a look at example 5 on page 63 of your textbook, you'll see an example of one that's a second degree equation. You can see how much more difficult this is to graph. All the ones that we're going to be graphing are like the ones that you've done already.